Okay, good morning students. Today in this session we will discuss about the circular convolution. So, the objectives for today's session: how to represent DT signal as summation of impulse, and how to represent how to perform the linear convolution or discrete convolution, and how do you find out the response of the LTA system, LTA DT system using discrete or linear convolution. Then properties of linear convolution, interconnection of DT systems, and methods to perform linear convolution using graphical method, tabulation method, matrix method. So, in the last session we some of the problems we solved for the linear convolution. Okay. In today's session we will discuss about the how to perform circular convolution using linear convolution using circular convolution. Okay, what do you mean by that linear convolution? So, for any LTA system the output can be performed if you know, that is for any input sequence, if you know the impulse response of the system. So, x of n is 1, 2, 0.5 and 1, the sequence length of x of n is given, and the sequence length of h of n is given 1, 2, 1, minus 1. So, both the sequence length m and n are equal now. So, you can perform the circular convolution. First, if you want to perform the circular convolution, so in the last example both the sequence length starts at 0, but in this example the x of n sequence starts with 0 and h of n sequence starts with minus 1. So, in that case the output sequence starts with so the input sequence starts with n equals 0, the output impulse response start with n is equal to minus 1. So, the output sequence start with n is equal to 0 plus minus 1, n is equal to minus 1. So, if you perform by using this matrix method, okay, for the given sequence 1, 2, 0.5, 1, and the impulse sequence h of n is 1, 2, 1, minus 1, then if you multiply and if you add, then 1, the output sequence will be 1, 2 plus 2, 4, second sequence will be 4, the third sequence will be 5.5, 1 plus 4 plus 0.5. So, the diagonal elements must be added. So, 1 plus 4 plus 0.5, 5.5, and the next sequence on minus 1 plus 1 will be cancelled. Okay, the value will be 3 and minus 2 plus 2 will be cancelled. So, output sequence length will be 0.5, again 1 minus 0.5, 1.5, then final last one is minus 1. So, this is the output sequence length 4 plus 4. So, 8 minus 1 7. Then now the position starts from minus 1. So, the 0th position will be 4. Okay. So, next we will perform circular convolution. How to perform circular convolution? So, note the difference between the linear convolution and circular convolution. So, for any LTA system, the response of an LTA system can be found only by using linear convolution. Okay, the output response of the system performed using linear convolution. So, for that linear convolution, okay, the length of the sequence may be same or it may be different. But circular convolution is also called periodic convolution. So, here the sequence length m sequence and n sequence length for m and x of n and h of n must be equal. If it is not equal, by padding zeros, padding means adding zeros, they make the input sequence x of n and impulse h of n equal. So, for example, x of n is equal to 1, 2, 3, 4 and h of n is equal to the 3 sequence length 2, 4, 6. So, the x of n is 4 and h of n is equal to 3, n is 3. So, if it is not equal, you have to add 0. For a linear convolution, it may not be equal. You can perform the linear convolution 4 plus 3 minus 1, which is equal to 7 minus 1. This total sequence length should be 6. But if you want to perform circular convolution, the both sequence length must be equal. Okay. So, for circular convolution, so if the first sequence length is 4, second sequence length is 2, 4, 6, only 3. So, you have to add or padding zeros to make it a equal length. So, h of n is 2, 4, so only 3 sequence length. So, okay, here in this sequence 4, in this sequence 3. So, both must be equal. So, 2 forces, the remaining you have to add or pad zeros to make it equal length. Now, x of n and h of n both are equal, which is equal to 4. Now, you can perform this circular convolution using concentric circle method. Okay. So, concentric circle method. So, we will take the same example, another example circular convolution. So, 2, 1, 2, 4, 6, 0. So, how to perform by using linear convolution. Now, how to perform using linear convolution. This is circular convolution is okay, adding only 1 zeros, say both sequence length should be 4. But if you want to perform linear convolution using circular convolution, padding zeros. So, padding zeros means what? How many zeros has to be padded? How many zeros has to be padded? How many zeros has to be padded? So, that is m plus n minus 1, 4 plus 3 minus 1 is equal to 6. So, the sequence length should be equal, should be 6 in both the sequence. So, in both the sequence length should be 6. If it is not 6, then pad zeros or adding zeros. So, for the first sequence x of n 1, 2, 3, 4. So, length should be 6. So, the remaining 2 zeros has to be padded. Okay. Similar way, h of n is equal to 2, 4, 6, 2, 4, 6. The sequence length should be 6. So, that the remaining 3 zeros has to be padded. Now, if you perform circular convolution, the output sequence length should be 6. If you perform circular convolution, the both sequence length is 6. So, the output length also 6. But if you want to perform linear convolution, then you have to add the number of zeros to be padded is m plus n minus 1. So, the periodic convolution or circular convolution is also called modulo n, because different methods will see graphical method, matrix method, and the steps to be followed. The circular convolution, one of the main circular convolution, the DFT, discrete Fourier transform, supports the periodicity property. The DFT only supports circular convolution. So, there is a modulo n operation. We will see how to perform using concentric circle method. So, in the concentric circle method, there are two circles, inner circle and outer circle. So, in the inner circle, how to represent the sequence in a anti-clockwise manner, x of 0, the position, the angular position are x of 0, x of 1, x of 2, this is an anti-clockwise manner, and these are all finally should be add the sum of the products, so that the summation symbol, the outer circle. So, the second circle is the outer circle, so you have to represent the impulse coefficients, the impulse h of n sequences in a clockwise direction. Okay, this is h of 0 in clockwise, h of 0, then h of, so in a clockwise direction, h of 0 and h of 1, h of 1, h of 2, h of 3, h of 4. Then for each successive convolution, you have to rotate one sample in each time in a anti-clockwise direction. There are two circles. Okay, you have to multiply the values sitting on two circles with the same angular position, then after which the successive convolution values can be obtained by rotating the outer circle one at a time. So, multiply, so these are multiplying the value sitting on the same angular position, sitting on the two circles, inner and outer circles sitting on the same position, angular position, and finally summing the products. Okay. We will take one example, x of n is 2 1 2 1 and h of n is equal to 1 2 3 4. So, first we will draw the inner circle and represent the sequence x of n, and the outer circle to represent the values of h of n. So, the positions are inner circle x of 0 in anti-clockwise direction, x of 1, x of 2, x of 3, and the outer circle x of 0 in a clockwise direction, h of 1, h of 2 and h of 3, and represent the values. Okay. So, clockwise, this is anti-clockwise direction. So, represent the values of x of n. So, x of n values, what is x of n value? I'll write down the values. So, you have to multiply both the two circles in the same angular position and finally summing the products. So, the first sequence is 2 1 2 1, x of n value. So, x of 0 value is 2 and x of 1 value is 1 and x of 2 is 2 and this is x of 3 is 1. In a similar way, the h of n sequence, h of 0 is equal to 1 and h of 2 is equal to 2, h of 3 is equal to 3, h of 0 1 2 3, 4 values. Okay. So, now you have to multiply the values sitting on the same angular position. So, 2 into 1 plus 1 into 2 plus 3 into 2 plus 4 into 1. So, the finally the 2 plus 3 plus 6 plus 4, which is equal to, so this is 2, not 3, this is 2. So, in a concentric circle method, there are two circles, inner circle and outer circle. So, represent the sequence x of n in the inner circle in a anti-clockwise direction, represent the h of n sequence in a clockwise direction in the outer circle. To compute the convolution sequence, each time you have to rotate one sample at a time in the anti-clockwise direction and multiply the values sitting on the same angular position, and finally summing the products. So, multiply with the same angular position and finally summing the products. So, the second value will do. So, keep the inner circle as such values. So, the inner circle, the summation x of 0, x of 1, x of 2, x of 3, then outer circle. So, now you rotate one sample at a time. So, now the position of h of 0 shifted to the next position. So, one sample at a time. So, in a anti-clockwise direction, now the position h of 0 in this place h of 0, then h of 1, then h of 2, h of 3. Now, the values, the inner circle values are not changed. So, as such you can represent the inner circle values, and the outer x of n sequence now shifted to x of 0, x of 2, 2, 3, and the x of 3 will be 4. X of 3 is 4, the value is 4. So, the inner circle values are 1, 2, 1. Now, you can compute the convolution value, which is equal to multiplying the value sitting on the two circles with the same angular position. So, 2 into 2 plus 1 into 3 plus 4 into 2 plus 1 into 1. Four plus 3 plus 8 plus 1. So, 16. In a similar way, we can perform the next computation of the convolution sequence. So, keep the inner circle as such, inner circle as such. So, the values are x of 0, x of 1, x of 2, x of 3 as such. No need to change the inner circle, only you have to rotate the outer circle one sample at a time in an anti-clockwise direction. So, the outer circle. So, now the position of h of 0, h of 1, h of 2, h of 3 will be changed. Now, you represent the values h of sequence, h of n sequence values, then multiply and finally summing the products, you will get 14. Similar way, the last one. So, it is a 4 outputs, the sequence length is 4, no. So, the output sequence length also must be 4. So, the last computation of the convolution sequence, inner circle no need to change as such, and the outer circle rotate one sample at a time. Now, the position of h of 0 is here, and h of 1 will be here, h of 2 will be here, h of 3 will be here, then represent the values of h and multiply the same angular position. H of 0 values represent, h of 0 is 1, 2, 3, 4. So, you can represent this is 1, h of 0 is 1, then h of 1 is 2, 3, then h of 3 will be 4, h of 2 is 3, h of 3 is 4, and the inner no need to change. As such, x of 0, 2, 1, 2, 1. So, these values you can keep as such. So, x of 0 value is 2 and 1, then 2, 1. Now, you compute the convolution sequence, multiply the value sitting on the same angular position. So, 2 into 4 plus 1 into 3 plus 2 into 2 plus 1 into 1. So, 2 4s are 8 plus 3 plus 4 plus 1, 16. So, the final output sequence length is equal to y of n is equal to that is a 14, 16, 14, 16. So, this is a concentric circle method. So, in the concentric circle method, so there are two circles, inner and outer circles. Keep inner circle as such and represent the values in a anti-clockwise direction. The outer circle represent the values in a clockwise direction. Then each time rotate the outer circle anti-clockwise direction one sample at a time and multiply the value sitting on the two circles to the same angular position, finally summing the products. So, this circular convolution we can perform by using matrix method. We will take the same example 1 2 1 2 and 1 2 3 4. So, in the matrix method, so the sequence length, so 2 1, so to represent 2 1 2 1, then you rotate in circular fashion. So, now the bottom one comes to the top one, then it will be shifted by 1 to the down. So, this can be represented, this angular position can be represented, finally 2 1 2 1 2. So, then the second sequence h of n 1 2 3 4, then you multiply, normal multiplication, you can perform the first sequence, 2 1s are 2, 1 2s are 2, 2 3s are 6 and 1 into 4 4. So, the sequence length, this output sequence will be 2 plus 2 4 plus 6 10 plus 4 14. So, the first sequence length is 14, okay, 14. The second sequence length will be 16 14 16. Now, how to perform linear convolution using circular convolution? Using circular convolution. How to perform linear convolution using circular convolution? So, normally how do you represent the linear convolution? X of n, this star symbol h of n, this is the convolution symbol. How to represent circular convolution? This y of n is equal to x of n star and put a circular over that, that is a circular convolution, and h of n. Okay. Now, we will take example x of n is 1 3 1 3. So, m sequence length, h of n is 1 2 1. So, m sequence length, this is n sequence length. So, m plus n minus 1, this is equal to, in linear convolution, 4 plus is 6. If you want to perform, okay, linear convolution using circular convolution, the sequence length, how many zeros must be added? 6, no? So already 4 sequence length, the remaining 2 zeros has to be padded. For the sequence h of n is equal to 1 2 1 3, so the remaining 3 zeros has to be padded. Okay, now you perform circular convolution. So now if you perform circular convolution, which is equivalent to the linear convolution value. If you want to perform linear convolution through circular convolution, both the sequence lengths must be equal. If they are not equal, then how many zeros has to be padded? M plus n minus 1, the total sequence length for each sequence should be 6. So in the first sequence only the sequence length is 4, so 2 zeros must be padded. In the second sequence, as h of n, only 3 sequences are there, so the remaining 3 zeros has to be padded. Now if you perform the circular convolution, you will get the linear convolution. Okay, so what is the general linear convolution for the 4 sequence 1 3 1 3 and 1 2 1? So the output sequence length will be y of n is equal to 1 and 3 plus 2, which is equal to 5, and the third sequence will be 8, 1 5 8, fourth sequence will be 3 plus 6 plus 2 8, 8 comma 8, and the fifth sequence will be 1 plus 6 and 7, and last sequence is 3. So this is 6 output sequence length. If you want to perform the circular convolution, then you take this sequence x of n is 1 3 1 3 0 0, and h of n is not this one. We will take matrix method. Take matrix method. So in the matrix form, you take 1 2, one of the sequence 1 2 0 0, then the second sequence is 1 3 1 3 0 0. Then you can perform the output sequence will be y of n is equal to 1 for the first one. So the second one, 2 1s are 2 plus 1 3s are 3 plus 2 5 5. The second sequence will be 5 5. Similar way you can compute all other sequences. So other sequences will be 1 5 8 8 7 and 3. So now these both are equal. So you can perform the linear convolution using circular convolution method. Okay, so hope that you understood the linear convolution, what do you mean by linear convolution, and what do you mean by circular convolution, and how to perform the linear convolution by using concentric circle method, and how to perform this linear convolution using circular convolution. Okay, thank you.